Hello, higher algebra students. Back here with Unit 12, Lesson 1, which is transformations. And this entire unit is covering exponentials, so we'll jump right into it here. So the objective in this first lesson is really just to refresh our understanding on transformations so that we can build up into these transformations in an exponential scenario. Again, transformations would include translations and reflections. So just a reminder of some of our parent functions here. So we've got the y equals x squared function, the y equals x cubed. Begin by changing the degree. Now we've got different end behavior. We talked about absolute value way in the beginning of the year. Square root of x we talked about a little bit when we first talked about reflections and translations. And then last unit we talked about this 1 over x. So our new function that we're going to be talking about here with exponentials is the idea of being, say, y equals a to the x, and looking at what happens when we have that exponent as a variable. Obviously, we haven't looked at that yet. We've only worked with numerical exponents and the variable being the base. Now we're going to have a numerical base with a variable exponent here. So just again, a follow-up with these parent functions. Each has their own unique table of values. So we started with the y equals x and y equals x cubed, squared, absolute value of x, root of x. Last unit, again, we had 1 over x. Here was that table that we talked about a lot last unit. Now, in this unit, just as an example, to put a base in there, again, obviously none of these really have numerical values outside of the 1 there, and of course an exponent on these x squared and x cubed terms. But if we were to say 2 to the x, and again, just look at, say, a negative 2, negative 1, 0, 1, and 2 as x terms, then our y terms, 2 to the negative 2, so 2 to the negative 2 is equal to 1 over 2 to the 2, so this would be 1/4, 1/4. 2 to the negative 1 would be 1 over 2 to the 1, so that would be 1/2. 2 to the 0 is 1, so at 0 that'd be 1. 2 to the 1 is 2. 2 squared is 4. So that's what our table would look like. Now what you're seeing here, and what you're going to see that we is a little bit of a connection here, is that there is an asymptote in play here again. And that asymptote is the notion that no matter how small we go with our x term, okay, 2 to the negative 1/1,000,000th, it still technically does not equal 0 at that point. So we have an asymptote at a y equals 0 value. We'll never get there, even though if you were to say type into your calculator 2 to the negative 100,000 or 1,000,000, it would show 0. That's a limit idea that you'll talk about as you progress through a math curriculum. But for right now, we would look at this technically as a horizontal asymptote at y equals 0. And we'll talk about that a lot as we move forward. So just a quick refresher on the idea of horizontal or vertical translations. So again, we talked about this a little bit last unit, that if we had, say, 1 over x, plus 2, that would be moving left to 2 units, because our vertical asymptote would then be at x equals negative 2, because again, we can't let that denominator equal 0. So a negative 2 for x is what would make it equal 0. So that's just a reminder that when you add, you're actually moving left. And similarly, if we were to subtract 2, now our vertical asymptote would be at x equals 2. That means that this would be moved 2 to the right instead of 2 to the left. Like, not that, like this here. Because here's our vertical asymptote at negative 2, here's our vertical asymptote at 2. So that's again being moved to the left or the right, knowing that our parent function for 1 over x looks like that. Vertical translations happen afterwards. So again, if we have 1 over x plus 2 versus 1 over x minus 2, now similarly, as we saw again with this parent function of 1 over x, 1 over x plus 2 means we would just take our original graph and move it up 2 units. And then you'd have, oh, sorry, that's not a beautiful horizontal asymptote, but that horizontal asymptote would be at y equals 2. And then similarly, if we moved it down 2 units, it would look like this with our horizontal asymptote at y equals -2. So you can see again, this works whether it's absolute value of x, x squared, x cubed, root of x, doesn't matter. The same rule for, again, horizontal translations occur within the x, almost like there's a parenthesis there. Vertical translations occur after the x or before, it doesn't really matter. It could be 2 plus 1 over x, it's the same thing, but the calculation is outside of the realm of the x there, and that'd be our vertical translation. Now on the reflection side, again, we've got two different types of reflections, reflecting over the y-axis or over the x-axis. And again, over the y-axis, which is a horizontal reflection, since the y-axis is the vertical axis, so we'd be reflecting from here over here, that is where the negative is inside, applied to the x inside the parentheses, versus a reflection over the x-axis, which is a vertical reflection. Again, that means we'd be going something like this. That is where the negative is out front. So if we took, for instance, y equals x squared, here this would be on the applying to the x, this would be y equals -x squared. And over here, this would be y equals -x squared. So if, let's say x is 2. So that means originally it would be y equals 2 squared or 4. So the point would originally be at 2, 4. In a horizontal reflection, again, this would be going to the other side of the y-axis. So this would be, if we put 2 in for x, this would now be at -2 to the x again, but we'd still have an answer of 4. So this would be the point -2, 4. Knowing that we've taken the 2 and made it a negative proactively here. So that's the idea of, yes, we still use an x of 2, but what we're saying is we're proactively applying a negative to it, so we are making it the opposite x term. Versus on the vertical reflection, if we put a negative out front and this is just 2 squared, well, this would be y equals -4 because 2 squared is 4. So now we've got that idea of changing the y value from 4 down to -4, whereas here we change the x value from 2 over to -2. So they're again applying that negative inside, and what that does to our reflection over the y versus the negative out front with the reflection over the x. So here are just some examples where we have what would be a parent function here, for instance, of y equals x cubed, and we're applying transformations here. So again, what we've got is we've got a -9 on the inside, and then a -7 on the outside. And this -9 on the inside then is going to be our horizontal translation. And again, what would bring that back to 0 would be an x equals 9. So this is translated 9 units right. And the -7 means it's translated 7 units down. Okay. In the second one, now we've got the -x in the second one. So that -x, again, from the last slide, that -x is a reflection over the y-axis, which again is a horizontal reflection. That's that negative, the negative within the x versus the negative out front. And then again, the 4 units up means that it's translated 4 units up. Sorry, that's the +4. Means it's translated 4 units up. And continuing on, here we've got a negative out front, a -1 under the root, and a +2. So again, our parent function here is root x, just like up here it was x cubed again. And so the negative out front that would be a vertical reflection because it's a negative up front. This -1 would mean that it's translated 1 unit to the right, because again, you put a 1 in there. 1 minus 1 brings it back to 0, so you kind of look at what would be that kind of brings it back to the start, and so the minus actually moves it to the right. And then the +2 would be 2 units up. And then finally, we have an absolute value, equals absolute value of x here. And again, we've got a +2 on the inside, so that's 2 units left. And then a +1 means 1 unit up on that one. So all these little individual translations or reflections, again, looking at when is there the negative up front or a negative in front of the x directly for our reflection, and then when are we adding or subtracting within the parentheses, and then adding and subtracting to the end or on the outside for our up and down translations. So now going the other direction here where we are given the translation and just being able to write the formula here. So we have the parent function y equals x cubed down 9 units. Again, down, up and down is what comes after, and because it's down, it's a subtraction. So that would be a x cubed minus 9. We've got parent function of absolute value of x. 2 units to the left. Again, horizontal translations occur within the, in this case, absolute value. So left 2 units, oh, sorry, didn't mean to do that. Left 2 units would mean that we had to have gone with an x plus 2, again, because we want the, if we put -2 in here, that's what would make the interior of the absolute value equal 0. So we need that, so left 2 would be a -2 there. So again, if we put a -2 there, that's what would equate to left 2 units. And then down 6 would be a -6 at the end there. Third one here, we have absolute value of x, and it's to the right. So let's, within the radical, to the right 4 units means that we would subtract. Again, if we put 4 in for x, which is to the right of 0 on a number line. Again, when I say to the right or to the left, 4 in for x would be over here, which is to the right. Just like last one, -2 in for x would be the left. So I put 4 in for x so it'd be 4 minus 4 under the radical. And again, up 7 units at the end would make it +7. And then the last one here, we have a parent function of x squared. It's going to be reflected over the x-axis. So again, reflection over the x-axis is a vertical reflection, and a vertical reflection puts the negative out front. So it'd be a negative of x squared. And then again, down 11 units would look like this. So the reflection over the x-axis is that negative out front, again, because it's vertical. So this is same as saying a vertical. And then translated down again is the -11 at the end. So now let's actually put these into practice on some graphs here. So as a reminder, the absolute value graph of x looks something like this, where we've got the point 4, 4, and we've also got the point -4, 4, because the absolute value of -4 is also 4, and so on. So we think about this idea of the kind of the V shape, but the -3 means that we are translating 3 units to the right. So we're looking at this going 1, 2, 3, but then we've got a +2, so we're also going up 2 units. So right here would represent kind of the bottom of our V. So what originally would look like this going out is now going to look like this going out. So for instance, this is the point 3, 2. If we put absolute value of 3 minus 3 plus 2, well, 3 minus 3 is 0, plus 2 is 2. So there you can see it. This was our x, and there's our y. If I put in 4 for x, so I'm going to, we've got x equals 3 now. Let's put in 2 and 4 for x, just to kind of finish this and see what we see. So y equals make this actually not yet. I'll put the absolute value, and then I'll make this. This is our x of 2. Okay, that would be that 2. And then we subtract 3 and add 2. So that would be y equals the absolute value of negative 1 plus 2, which is 1 plus 2. So the y here would be 3. So that means when x is 2, y is 3. So that would be right here at, not negative 2, just 2, at 2, 3. If I put in 4, you can see I'm going to get much the same here if I put in 4 for x. So let's just make this a 4 now. Then this would be a positive 1 absolute value, and that would be 1 plus 2, so that would also be 3. So 4 would be 4, 3. And again, if I put in 5 here, then 5 minus 3 is 2. 2 plus 2 is 4. So I'd have 5, 4, and so on. So I still keep my diagonal pattern here, going over 1 and up 1 each time. It's just that I've moved it 3 to the right and 2 up based off of the original horizontal translation and vertical translation that occurred to begin with. So here's another one. This was originally y equals x squared, and again, y equals x squared looked like this originally. And we moved it with this plus 2. That means we moved it 2 units to the left, because a plus is to the left. If I put in negative 2, negative 2 plus 2 is 0. So that's where I would have kept it at 0, just like 0 starts at 0. 0 squared is 0. But then I subtract 3 here. So I'm going to move this down 3 units. So what we expect to have happen is from here, again, rather than it kind of being like this, we expect it to kind of go like that from here now, because we moved it 2 to the left and 3 down through this translation. So again, this would be the point negative 2, negative 3. And so if we put this into our xy, and again, negative 2 is one of the points. Well, just to show here, negative 2 plus 2 squared. Negative 2 plus 2 is 0, so 0 squared minus 3. 0 minus 3 is negative 3, so negative 2 should have gone to negative 3. Again, that's the point we had. So now we go a couple more points. If I go with the negative 3 point, negative 3 plus 2 squared minus 3, well, that would be negative 1 squared minus 3. Negative 1. So negative 1 squared is 1. 1 minus 3. And 1 minus 3 would be a negative 2. So negative 3, negative 2 would be this point right here. And then if I put in negative 1, change that color again. So negative 1. So negative 1 plus 2 squared minus 3. Well, that's 1 squared minus 3, which is the same thing as we just did. So this is also negative 2. So that's the point negative 1, negative 2. Now, from there we could continue checking negative 4 and 0 and so on. So negative 4 plus 2 is negative 2. Negative 2 squared is 4. 4 minus 3 is 1. 0 plus 2, again, if I put 0 in here, plus 2 is 2. 2 squared is 4. 4 minus 3 is 1, and so on. So you can see this is going to continue going up. Just like our x squared graph that we're used to, it's just that it started 2 units to the left and 3 units down because of the original formula. So here's another one here where we have y equals root of x as the parent function. And again, the graph for root of x looks something like this. Now what we have to look at though is we've got a negative here and a negative here. So again, the original function is 1, 1, 4, 2, 9, 3, and so on. This starts to get a little goofy with that negative inside. You don't want to get stuck in the whole negative square root idea, but the notion of a negative and inside next to the x is there a horizontal reflection. Okay, so again, this is a reflection over the y-axis. Over the y-axis, which is horizontal. So that means this would go over to the left, which would be a negative 1, 1, a negative 4, 2, negative 9, 3, and so on. So it would look like that. But the actual final answer now has to take into account the negative out front. And the negative out front is a vertical reflection, or over the x-axis. So we've got a double reflection here. And so we end up at a negative 1, negative 1, a negative 4, negative 2, a negative 9, negative 3. So our actual final answer is the blue graph here when we complete our second reflection. So a reflection and a reflection, it actually ends up being a rotation. We've basically rotated this graph around one way or the other, 180 degrees. But a reflection and a reflection here occurs because of the negative that we have with the x and the negative that we have out front of the whole term. Look, one final one here. This is an x cubed, but the negative within again. So a negative within, just as a reminder, a negative within is a horizontal reflection. And that means it's over the y-axis. Because again, horizontal would be this way, and this is the y-axis here. So the original function is y equals x cubed. And y equals x cubed would be the points 1, 1. 2 cubed is 2 times 2 times 2, which is 8. So it's 2, 8, and so on. Negative 1 cubed is negative 1. Negative 2 is negative 8. So it actually kind of looks like this. The original function, that is. But now again, we're reflecting over the y-axis. So as you can see, reflecting over the y-axis here would basically flip this. And so instead of going bottom left to top right, it's now going to go bottom right to top left. So instead of this point reflecting over this axis, now it's here. Instead of negative 2, negative 8, now it's 2, negative 8. Instead of 1, 1, now it's negative 1, 1. Instead of 2, 8, now it's negative 2, 8. And so our new graph, the red one here, would look something like this. And that would be our horizontal reflection over the y-axis. So it almost creates this sort of scissors look or crossover look here that because of the nature of the graph. But again, that's that negative within the parentheses that causes that horizontal reflection over the y-axis. Thank you as always for listening, and please let me know if you have any questions.